Okay, hello again, my pre-calculus students. We're going to try this again and finish up 7-4. This is part 2 of 7-4. I'm going to mark it right here, part 2. You can recall that in part 1, we did the double angle identity. And I already looked at the My Math Lab homework, and I would say about 90% of you nailed those few problems that I gave you in My Math Lab. So you did a very good job. So you either did well because of the last lecture or the introductory video that I sent you from YouTube hit the spot. Either way, you did a great job. So now, as I said, we've already covered this one. We did not do the application, so let's look at an application. I mentioned to you that there are product to sums and sums to products, and I'm not going to hit that real hard only because as I told you yesterday, I don't think I've ever used those. Never had a reason to come up other than a math teacher telling me to do it. However, half angle identities, it definitely does come up. And of course, verifying an identity, it means proving an identity, which we've done that before. We have the left side, we have the right side, and there's an equal sign. And what we have to do is, again, we have to manipulate one side or the other and keep working it until bingo, it looks like the left side. That's the hard part. That really is the hard part. All right, let's get to work. If a toaster is plugged into a common household outlet, the wattage consumed is not constant. Suppose you didn't realize that. You figured you plugged in the toaster and it's so many volts. You just assume that everything's constant because the voltage is constant, but it's not. It varies at a high frequency according to this model. So your wattage is always going to be your volts squared divided by R. R stands for resistance. And resistance occurs in electrical wiring for a lot of reasons. The temperature of the wire at that moment can change resistance. If it gets really hot, there's a lot of resistance and so forth. So graph the voltage W consumed by a typical toaster with R is 15. So the resistance is typical at 15, and V is 163 sine of 120 pi t. So voltage is a trigonometric function. The resistance is constant in this toaster. The window, this is how he wants us to graph it. How many oscillations will there be between the angle of 0 to the angle of negative 500? He didn't tell me if I was in radians or in degrees. Well, guess what I'd be taking? Did he mention it? Well, I'm going to do it both ways and see which one looks good. So I'm going to pause this right now, and I'm going to go to my calculator, and I'm going to graph it. And actually, I'll put a blank screen here. Well, I'll put it there, my picture. But I need you to do it also. Either use a graphing calculator, or you could use Desmos. And you can get Desmos online, and it has a graphing calculator, desmos.com, if you don't have your calculator with you. But I'm sure most of you have your calculator. So I'll be pausing and I'll come back. And when I come back, I will pause it. I'll be recording a pause to give you enough time to get it done. FYI, it is radians. Make sure you don't forget to square the numerator. Giving you a few more minutes, a few seconds. There's the window. There's the function. There's the graph. So by looking at the graph, he wanted to know how many oscillations. Well, look at it. It starts here. Starts, goes up, and look what it appears to be doing. Starts over again here. 2, 3, 4, 5, 6. Just a graphing exercise. And there is 6 oscillations. Wow, that was fun. All right. Product and Twosomes identity. What it means is, what if you had, and I told you I've not really needed to, you had a sum or a difference of angles, 2 different angles, and you want to convert them into a product. Well, we already know the identity. Cosine A plus B is cosine A, cosine B plus minus. Sorry, we switched the signs for sine. Sine A, sine B, cosine A minus B is cosine A cosine B plus, well, cosine A plus B plus cosine A minus B is a sum and difference of two angles at the same time. You put that together, turns out to be 2 cosine A cosine B, but you've not seen that before. Well, you have had cosine A times cosine B if you think about it, but divide this by 2, that gives you the half of cosine A plus B plus cosine A minus B. That is fun, but I really can't say that I needed to take this product of cosine A, cosine B, convert two separate cosines. Because to me, it's not, this is more simple than all of this. But what's those products? Here we had plus and we had the minus. Original we just did. You see what he had done here? This is you're adding or subtracting. In this case, he was adding. So you added all of this, added to all of this. So one, that's why there's one of each. But he started out with a plus one first. Then, who knows? Now, the other way around. If you want to go from a product to a sum, what we just did right now, what's he going to say here? Subtracting, oh, he's doing the subtraction. It's the same thing. You know, you got your cosine A minus B, cosine A plus B, whereas that was the order. So cosine A minus B minus cosine A plus B. Do you see where, let me go back to one is, you're starting out with a minus one first. And in this case, he's not adding them. Let's see what he's doing here. He is subtracting. So you get this minus this. And then if you're careful and see all of this, subtract all of this. So technically you've got to distribute a negative here. So you have your cosine A cosine B minus cosine A cosine B. Well, that disappeared. That cancels out. Sine A sine B minus gives you plus. So that's why you're back again to 2 sine A sine B. Divide both sides by 2 again. Miraculously, you have another identity that I cannot say I've ever really used other than when a math teacher made me do it, which hasn't been that often. You may never see this ever again in your life. The cosine's in there. All right, going the other way around. Using the identities for sine of A plus B and sine of A minus B in the same way, we obtain 2 more identities. So what we had a minute ago, we were using, now we're doing sine. So the product of sine A, sine B, if you had, sine A and cosine, that's should look familiar to almost like a double or a sum of sines. To turn that product into a sum, well, you take sine A plus B, both of those angles, and you add it to sine of A minus B. Likewise with your cosines. Cosine A sine B, that's basically you just reversing those, the other order. But that turns it into a difference, not a sum. But a difference really is a sum. Minus minus. Difference of a difference is still a sum. So again, another possibly useless identity for you. What do most of us do in real life? Since you never use it, and the odds of it coming up is slim to none, we know that if I ever had to break this product into a sum or a difference or differences, we know that we have a chart. We could look it up. You would just have to remember the name of it, product to sum identities. You can Google it right now and find this chart. So let's try to use this. Write 4 cosine 75 sine of 25 as a sum or difference. So he's telling me to do it. And since I'm not expecting you to memorize it, if you had the chart and like I'm showing you, you Googled it and you found this, and you ask yourself, well, which one do I have? Well, I have a cosine times a sine, cosine times a sine, A and B. You probably could use both of those, to be honest with you. So just jumping out, looking at this one right here, got to get rid of that 4. So obviously that 4 has to be, in a sense, factor the 4 out. Here's A, here's B. So we know it equals to 1/2 of sine of their sums. 75 plus 25 is 100 minus their differences. 75 minus 25 is 50. Whoops, I'm sorry, sine of 50. I make so many more mistakes when I don't have you in front of me. Sine of 50. And I probably make mistakes I don't even catch. But don't forget, I got to divide by 4 on both sides. So there's technically a divide by 4, which means the 4 and the 2 go together. So we should be looking at 1/8 of sine of 100 minus sine of 50. Those are not special angles, so I probably won't have the answer to it in my head. I'd have to use my calculator. But I mean, if I'm going to use my calculator on this, I could have used my calculator on the original problem, couldn't I have? Let's see which ones he gives us. You see what I did differently? And I can see my mistake. 4 of these would equal to 4 of these. So my answer, I put a 1/8. Should have been just a 2. Yep, 4 divided by 2. Wow. Yeah, I didn't. Wonder why I was thinking I had to divide. Now, I could act like I'm perfect and erase this part of the video. Nah. Gotta be me. Sum to products. If you were subtracting 2 angles of sine, or 2 angles subtracting or adding 2 angles of sine, you could memorize these. I wouldn't memorize it. Just use it if you have to. I'll save that one for you because, again, I have never, ever needed this before in my life. I mean, why would you go from something simple to something hard? I'm not even going to do that problem. The answer is there, but was dealing with fun with it. Half angle. Aha, this is the important one. So half angle identities, when we did sine of 2x, that's a double angle. Well, what if I was doing sine of x over 2? That's a half angle. And theoretically, he's saying we could use these to derive the half angle ourselves. And I'll give you a clue. This angle is half of this angle. So if I wrote this out differently, I could write it as cosine of x equals 1 minus 2 sine squared of x over 2. So really what I'm doing is I'm using the double angle identity and realizing a double angle means the other part of the other part has to be half. So if I put a half angle here and put the whole angle here, half here and whole here, solve this for my half, maybe I will have my identity derived. So sometimes what happens is, if you can't remember all your identities, but you can remember a couple, like of your double angle, it's killing two birds for the price of one. So I will solve this I'm going to solve it for this side right here. That means I'm going to subtract 1 from both sides, then divide both sides by a negative 2. So far that looks like this. Cosine of x subtract 1 divided by a negative 2 will equal to sine squared x over 2. Now, that negative is in a bad place. So what I'm going to do is move this negative to the top, and I'm going to distribute this negative to make this look different. Because I don't want you to get in trouble with a square root of a negative 2. So that makes this negative, this positive, 1 minus cosine of x over 2 is now equal to sine squared x over 2. And what would I do to get rid of the square? I can hear you all right now just saying, I know, you're going to take the square root of both sides. Yeah, you are. So that gives you sine of x over 2 equals 2. Well, I know you're dying to say plus or minus the square root of 1 minus cosine of x all over 2. Let's see if you're right. Is that what I had? 1 minus cosine of x over... Yeah, I have it. That was the double angle of cosine. Those were... I mean, you could have gone it either way. You could have taken... Either way, it's a double angle of cosine, double angle of cosine. You could have... Well, it's the same problem. It was 1... Yeah, he just solved this for that one. Doesn't really matter. Well, he did the is 1 minus cosine of... He did a instead. 1 minus cosine of a over 2. And there is plus or minus. And that just depends on which quadrant you're in. Because remember, sine is positive here, sine is positive here, or sine could be negative here, sine could be negative here. That wasn't too bad, was it? First one we just did. Now we can start with 1 minus... Oh, I see. You just did that a different way. Okay. I did half angle of sine, right? Let's see. How about starting out with a... That looks like the same thing. Oh, I think I just left it blank to work on. Extra slide. Okay, half angle of cosine. Let's see if we can do half angle of cosine. So I'll start with this again. I'll just write it out. Cosine of 2, make that an x, equals to 2 cosine squared of half of the 2x, which is x over 2, minus 1. And again, these identities we had with the double angle identities of sine and cosine. So this one's going to be easier because I'll move the 1 over, cosine of x, add the 1, divide it by, this is cosine, divide it by the 2, now equals to cosine squared of half of the angle x. Take the square root both sides, and you get plus or minus the cosine of x plus 1 divided by 2. All of this is in the square root, equals to the cosine of half of angle x. Let's see. Or did he not? What is that? He's got 1 plus cosine. There it is. And of course, cosine can be positive here in these two quadrants, 1 and 4. And it's negative in these 2 quadrants. That's why there's 2 possible answers. Wow. Well, tangents. Half angle of tangent. I think I like what he did, this one right here. If you remember what the half angle of sine had the minus, and the half angle of cosine had the plus, and they're the same answer, then sine over cosine is always tangent. I like this quite well, this method of just doing sines over cosine. I've seen another formula for half angle of tangent, but what it basically does, it'll just give you these. It'll just give you the answers, but this is where it comes from. What happens in this part, it all goes under one house. When you take the top fraction divided by the reciprocal of the bottom fraction, the 2's cancel out, and that's why you're left with that. In the sine, tangent of using the sine over cosine, let's see, this is another way. We already had this from another identity. It's a double angle of sine. So since if you double, well, it's just forget what I'm saying. I use this one. This one, the derivation looks a little more confusing. Staring at it, wonder why he went and used this one. It's a double angle of sine. That's what he did. It's a double angle of sine, and the angle was a over 2, and this was the double angle of cosine 2, so that's double of that angle. That's too confusing. And the beauty of this is, as always, that's that same answer. All said and done, those are what most of us will resort to. These two come up in calculus, but once the kids are reminded that sine has sine has minus and cosine has the plus sign, even if they don't remember it, I don't care. I mean, Google it once, do a couple problems, and you'll have it in your head just at least for a day. But if you don't use it, you'll lose it. And we do lose this. So, you've got to know where they're at. And we used to say, back of our math book always has them. And it is true, but that was before we had Google. Cosine was plus, the sine one is minus. Let's try to use them. Find the exact value of cosine of 15. Now, why do I know I would use a half angle? Because if I double 15, it's 30. Cosine of 30 degrees, well, we know how to do that. And so this is the half angle of this. So A is 30, if you think about it, 30 over 2. So I'm really looking at cosine of 15 degrees. So A would be 30. A would be 30. So using that formula, cosine of 30 over 2 degrees, which is 15 degrees, is equal to plus or minus the square root 1 plus cosine of 30 degrees all over 2. Special triangle. That's 30. 1, 2, square root of 3. Let's plug it in. We're going to have plus or minus square root 1 plus cosine of 30 is adjacent over hypotenuse. That's the square root of 3 over 2. That whole answer divided by 2 inside the square root. So let me copy this here. Yeah, I just copied it, or at least I selected it. Now I'll copy it. Let's see, how do I copy? And put it on new. Did I not do that? Piece of there. Okay. So the algebra is really ugly. 1 plus square root of 3 over 2 all divided by 2. 1 plus square root of 3 over 2 all over 2. You could do this a lot of ways. You could make one fraction on top, put a 1 over there. Common denominator is 2 over 2. So that gives you plus or minus square root of 2 plus square root of 3 all over 2 all over 2 again, which means 2 over 1, which means that 2 gets multiplied by this 2. So plus or minus square root of 2 plus square root of 3 all over 4, which is plus or minus the square root of 2 plus the square root of 3 all over 2, because the square root of 4 is 2. Well, that was fun. Let's see if it's right. Drum roll. I don't think I... Square root of 2 plus the square root of 3 all over 2. Why is he only using one of them? Did he say something earlier? Could have been plus or minus. Oh, he chooses the positive square root. Why? I don't know. He didn't tell. Oh, probably because the original cosine was in quadrant 1. Yeah. That's quadrant 1. Think about it. If that's 15, that is half of 30. 30 is also in quadrant 1. Yeah, quadrant 1. That's why we choose the positive. Did it? Find the exact value of tangent of 22.5. Now, nobody knows that in their head. You would have to be thinking, oh, wow, 22.5. That's half of 45. Okay, so what we're really doing is tangent of half of 45 degrees. And the formula that I don't really want to derive ever again would be sine of the whole angle, 45 degrees. And I gave you all of them that are here because nobody's going to memorize them. Let's just face it. 1 plus cosine of 45 degrees. And the reason that this works out nice is because we know all about the 45 degree. 1 square root of 2. And both 22.5 and 45 is in quadrant 1. So either way, I know the answer is going to have to be tangent's positive there. So equals to sine of 45 is opposite over hypotenuse, 1 over square root of 2, over 1 plus 1 over square root of 2. That's going to be, adjacent over hypotenuse, 1 over square root of 2. So what do I do with that? Is 1 over the square root of 2 divided by the square root of 2 over square root of 2 plus 1 over square root of 2, getting a common denominator, is 1 over the square root of 2 over square root of 2 plus 1 over the square root of 2. Since both of the denominators are the same, when you multiply by the reciprocal, they cancel out, leaving 1 over square root of 2 plus 1. Whatever that answer is as a decimal, you could approximate it, but that's the exact answer. Let's see if we're right. Look. There's nothing wrong with this answer, but do you remember that below calculus, those teachers always think you can't have a radical denominator? Okay, more work. Goodness gracious. Square root of 2 minus 1. Remember, we had to multiply top and bottom by the conjugate of the denominator. Because why? Because they don't like the answer of 1 over the square root of 2 plus 1. I love the answer 1 over square root of 2 plus 1. But I bet you any money your My Math Lab won't like it. Because My Math Lab was made by teachers who think it's so important. Distribute, square root of 2 minus 1 over. What was that secret when we multiplied by a conjugate? The outside and the inside are all that you have left because the outside and inside added, I'm wrong. You have the first times first and the last times last, but the outside and inside cancel out because they're the same thing, just opposite signs. So square root of 2 times square root of 2, that just turns into the 2. And 1 times 1 is minus 1. Final answer, square root of 2 minus 1 over 1, which I square root of 2 minus 1. Let's go back. Lanes over 1. Well, that was like 15 minutes of my life I'll never get back again. Let me go back to my formula. Example 10. Now you know why I broke this up in 2 days, 2 lessons, because we're on example 10. Given the cosine of an angle called S is 2/3. I got to pay attention here what quadrant I'm in. He's talking about between 2 pi, which is all the way around, and 3 pi over 2, which is right here. He's talking about quadrant 4, right here. Find the cosine of the half angle, whatever that angle is. Now, we are in quadrant 4. Cosine of the original angle is definitely, S is, hold on. S, this one here, is definitely in quadrant 4. Half of that angle will not be in quadrant 4. Half that angle. Let's just take the let's go all the way to almost 360 degrees. Let's do 358 degrees. 358 degrees. If you do half of that, that gives you a 1, 1 left over, and 2 goes into 15 7 times, 1 left over, 9. So that puts you at 179. That's as far as it's going to go, and that is going to be right here. So the cosine of the half angle is going to be in quadrant 2. Let's keep that in mind. This is in quadrant. We are actually in quadrant 2. Okay. Because S is in quadrant 4. Half of S is in quadrant 2. He wants us to find all of find the cosine, the sine, and the sine. So I did give you the cosine. I guess we'll do that one first because I think over 3 slides. So in case you don't have them memorized yet, there it is. The cosine of S over 2. Now, is going to be the formula will be 1 minus the cosine of the S all over 2. So we're saying, okay, what is the cosine of S? Well, he gave it to me. Hello, he gave it to me. That answer is done. And since we're in quadrant 4, that's down here, right? That's this triangle down here. Cosine's positive there. So, and he even said it is positive. Let's plug in the answers. The cosine of half of S will be square root, and it's going to be positive because we're in quadrant 4, and half of that, I'm sorry, I just lied. Half of that is in quadrant 2, remember? So it's not going to be positive, it's negative. Cosine's negative there. I almost messed up, see? If I had you guys in watching me, you'd be catching it. 1 minus 2/3 all over 2 minus 3/3 minus 2/3 is 1/3 divided by 2, which really means negative square root of 1/6. We'll check our answer afterwards. I hope I'm right. All right, let's do it there. Cosine's negative. Cosine was plus. Oh, I even wrote it here, but I didn't use it. Oh my gosh. You know, if I don't catch my own mistakes and somebody sends me a message, I was giving extra credit to my calculus students yesterday. All right, got to fix the cosine one up. That's a plus. 3/3 plus 2/3 is 5/3. 5/3 divided by 2 is 5/6. 5/6. Here I gave you, I broke it down into this one. We said a negative square root of 1/6. Let's write that out because we'll come back to it. Now we're going to do the sine. And to help you out, it was the one that had the minus. And since we already have cosine of S is 2/3, I just have to ask you, do you understand why it's still positive? Yes, I hope so. So sine of S over 2 will be, now, remember, half of that angle is going to be over here. Is sine positive or negative there? Sine's negative there. I'm going to have to use the negative of the square root. because it has to be negative. 1 minus 2/3 all over 2. Well, that's the same work. It's going to give me a negative square root. If I did my math right, 3/3 minus 2/3 was 1/3. 1/3 cut in half is 1/6. So that's negative 1/6, square rooted. Okay, we'll check our answer in a minute. Over here. Wait, I reversed it. Why am I saying negative? Did I not do that? It's positive. The cosine was negative and the sine is positive. Why in the heck did I put negative here? I don't know. Okay. I bet you, I feel it that you guys were yelling at me. Which one did I even sine? Which one had the... This one was okay because I did use minus. Tangent. And this is the one I prefer to use because I already have two answers. I said cosine was the negative square root of 1/6. I said the sine of it was a positive. Is that what I wrote? See, I find my own mistakes. I know you're yelling at me the whole time. And if I was live right now, I'd be getting a whole bunch of reminds. Okay. Anyway, tangent of s over 2 must be, sine was positive, so that was square root of 1/6 over cosine of 1/6. That was negative. And that, if you put that all under one house, that gives you a negative of a square root of 1/6 over 1/6. And that would be the negative square root of 1, which is negative 1. Wow, that's weird. I don't know if that's even the answer or not. We'll find out. Let's check our answers. Yelling at me. Oh, see, somebody. A lot of gobbledygook. Okay. Is that the same answer as mine? Let's check it out. Well, tangent doesn't look the same, that's for sure. Well, wait a minute. Tangent isn't looking at all like it. Oh, yeah, here it is. 1/6. Oh, I messed up on the plus sign. We go, oh. 5/6. And negative. There's the 1/6. And obviously my tangent's going to be off because I didn't use the 5/6. But it's okay. I can show you right here that it works out. Tangent of s over 2 would be the sine over the cosine. That one was okay. That was a square root of 1/6. This one is the negative square root of 5/6. That turns a negative of a big square root of 1/6 over 5/6. Since the denominators are the same, it should cancel it out, giving you a negative square root of 1/5. Now, you're saying, well, that doesn't look like his answer. Well, if you think about it, this really means negative square root of 1 over square root of 5. And the big bad people say you can't have a radical denominator, so square root of 5 over square root of 5, negative square root of 5 over the square root of 25, which is 5. It's the same answer. Yeah, I know what you're thinking. My math lab is going to make you do that work. I hope this is the last one because I'm tired. Okay. Simplify each expression. You just had to realize that this was a plus sign, so it had to be a cosine half angle. So why don't you just say it's cosine of the full angle. See, this is supposed to be, this is the full angle. half of that would have been how much? 6? I believe that's what that would be. Move to the next one. Okay, that was what? That's the tangent one, isn't it? It's a tangent one. Because it was the 1 minus cosine over the sine. That was how that final thing came. So this has to be the full angle. So I'm really looking at the tangent of half of that. Using A. So that's what it simplifies to. Over here. I put it down there for you. The answer to A, there it is. Answer to, yeah, there it is. Oh, I just realized I did. Problem? Holy cow. What, that wasn't the last. Another, oh, we got to verify. Okay, we have to prove that this side is equal to this side. There are 3 ways to do it. You could play with this, keep simplifying it till it gets to this, or you could play with this, try to turn it into this, or you could simplify both sides at the same time and see if they ever are equal. Choose your own poison. I think, I lied. He didn't want me to prove this is this. He wants me to prove this is equal to this. I didn't realize it. And the trick that I had shown you in the past was take the ugliest side and play with it. That's what we just did right here. He just did foiled it. He did the sine of x over 2. Wait, not that. Plus cosine of x over 2 squared, which means times itself. Sine of x over 2 plus cosine of x over 2. And using FOIL. Sine of x over 2 times sine of x over 2 is sine squared of x over 2. Sine of x over 2 times a positive cosine of x over 2 is plus sine of x over 2 times cosine of x over 2. Since the inside is the same, that also gives you the exact same thing, sine of x over 2 times cosine of x over 2. And then last times last is cosine squared plus cosine squared of x over 2. That's sine squared x over 2 plus 2 sine of x over 2 cosine of x over 2 plus cosine squared x over 2. Now, this gets hard. What in the heck is going to happen here? I see something that you don't see, and it has to do with Pythagorean identity. This angle is the same as that angle. This is a sine squared. This is a cosine squared. They go together. Tell me. I'm listening. Did you say 1? Then you'd be correct. 1 plus 2 sine of x over 2 cosine of x over 2. And I know what you're thinking, that this angle is the same as that angle, and this is a sine and times a cosine times a 2. That must have been a double angle identity. Double angle identity. So that turns into 1 plus 2 sine of 2 times of x over 2, which turns into 1 plus 2 sine of x. Am I close to what he wants? He's got just sine of x. Ooh, I'm still not there. Did I mess up? Stare at it. I'm going to try to see if you can send out your energy and tell me what else is to do. Ah, there's not another 2 here. Because this together is sine of 2 of these. Oh, okay. I hate it when it jumps at you and you stare at it for a second. But I think whoever was telling me, I heard someone yelling it real loud. I'm tired. Next problem. Oh, wait. That's the answer. Oh, I I put this down here to remind you of that identity. Hello. It's right there. There it is. It's all worked out. And yay, it's done. Okay. So I'm going to go start submitting this to YouTube. It takes about an hour for it to upload. And while that is being uploaded, I will be putting on my math lab the second part of lesson 4. It'll be short, just like the other one was. You're going to have the weekend to finish it up, but there will be a quiz on Monday, and we will start lesson 5 as well. I might find a Khan Academy that puts some of these identities together, because it's basically, the quiz will be on lessons 1 through 4, which is a lot of identities. I don't know how Khan Academy will do it, but you're gonna have a couple things to do this weekend. Sorry, you might seem like you're being pushed hard, but for you guys getting college credit, we have to get it all done. We have to. They're not even being nice like the high school is. I'll try to still work with you, though. You just got to tell me up front if you're having any problems. I will work on you. Some of you have extenuating circumstances going on at home. We all do. And this has not been easy. If I can help you in any way, just reach out to me. You got my remind. Bye, guys. I'll see you Monday.